My best wishes to all the viewers. Welcome back to the DT studio. Now I am handling the subject surveying 2. It is prescribed by Board of Technical Examinations. Directorate of Technical Education in Karnataka, Bangalore. Now we are discussing the trigonometrical leveling. Trigonometrical leveling. In trigonometrical leveling, we have discussed so many cases. Now it is the object of determining the elevation and distances, relative elevations and distances of the objects, faraway objects. Now when base of the object is accessible and base of the object not accessible, and single plane method and double plane method, we have discussed about it. And also we have solved a few problems in the previous classes. Now I will continue the same thing for 10 slides, 10, 12, 10, 15 minutes. I will recall the few things what we have discussed in the previous class, and I will solve 2 problems. I will give solutions. Let us discuss solutions to 2 problems, and then we will proceed with the tacheometric leveling. Then accordingly, now we know that this is the one instrument which is being used widely used by civil engineers to measure the horizontal and vertical angles. Isn't it? I think we are all more familiar with this instrument. You know, we are all more familiar with the instrument. Yeah, we should know. We must familiar. We should know about it. Okay. Now this is the one most versatile instrument. It is widely used by civil engineers and consisting of the leveling gate, horizontal circle, vertical circle, telescope. Like this can be used. The telescope can be rotated both in horizontal axis and horizontal plane and also in the vertical plane. That is the advantage of this instrument. And again, the trigonometrical functions. Without knowing the trigonometrical functions, we are unable to handle any problems related to trigonometrical leveling or tacheometric leveling. No, it is the basics. Trigonometry, basics of trigonometry, the one an engineer must know about it, isn't it? Our Polytechnic students are lagging in this. This causes their failures, isn't it? Therefore, please try to understand and go through the fundamentals of the trigonometry and also the calculus. And see, in trigonometry, we have discussed how to find out the elevation of the object 1, how to find out the elevation of the object 2, and how to find out the elevation of the object 3. Now, this is where the base can be accessed from the instrument station, where the base of these two objects cannot be accessed. Therefore, we have discussed about it. And these are the methods. These are the methods we have followed in finding out the elevation of the object. And now, when both instrument axis at both the instrument stations are at the same level, and these are at the different level. Now this is the related equation derived from this diagram. That is, considering this triangle, that is, this is the h height of the object above the instrument axis. That is, h is equal to d tan alpha 1, and similarly h is equal to, considering the second instrument station and the triangle, h is equal to b plus d tan alpha. Now, equating those two equations, we will get this. From this, we can calculate the distance between the first instrument station to the object, horizontal distance, isn't it? And similarly, in the second case, it is difficult to achieve this. So, difficult to achieve this situation. It takes too much of time. Therefore, now it is simplest. We have modified the triangles according to the instrument axis, and now we have modified this. Now this is here V is increased, and therefore here the same equation. Now V is increased by, that is S cot alpha 2. Now this is the equation where from this we can calculate V is known, S is known, the difference between the two stop readings, S is known, and alpha 2 is known, alpha 1 is known. Now easily we can work out, we can calculate the distance between the first instrument station to the object. Now similarly the case may be something in some situations it reverses. Now here in the first situation the instrument axis is lower level, in the second situation the instrument axis is at the higher level, and also now in the another situation the instrument axis of the farthest instrument station is lower and the nearest instrument axis is higher level. Therefore now this V is reduced. V is reduced by, this is S cot alpha 2. This distance is reduced. Now that is why the same equation, the same formula becomes V minus S cot alpha 2. And here we know all the, we have recorded all the readings. That is V is known, fixed by ourselves, and S is known, the difference between these two, and tan alpha 1 and alpha 2 are measured from the theodolite, vertical angles, alpha 1 and alpha 2. That is how we can calculate the we can calculate the distance from the object to the instrument station. Instrument station. Similarly, now these are the three situations we will come across while calculating, while landing the instrument, and method used to calculate the elevation of the given object and also the distance between the object to the instrument station. And now we have solved a few, we have discussed a few problems related to these situations, the first situation, second situation, and also the third situation. And similarly, now we will have one more problem. Now please read the problem carefully before calculating or before doing any action. First, now please understand, read the problem carefully. Read the problem, given problem. Read it carefully. Now I have prepared a diagram for the given problem. In the next slide, I will show you. That is, now see, in this problem, this is the fourth situation. In the previous three situations, both the instrument axes are at the same level. In the second situation, one axis is above, the other axis is below. And similarly, in the third situation, the one axis is below and the other axis is different situations we have come across. This is another situation where the instrument axes are a little more, isn't it? More. The difference is much more. The undulated area. Now here the problem is given like this: the instrument station from A, which is 1.49 meter above this instrument axis, isn't it? Height of the instrument HI is equal to, and the angle measured is 38°24', and the isn't it? So this is the measure. This is the first data taken, and in the second instrument station, a vane is kept here in the first instrument station, and the height of that vane is 1.2 meter. This is the given data, and the angle measured from the second instrument station to the first instrument station is 9°54', and also the angle measured to the object P is 26°/. Now the distance between the first instrument station and the second instrument station is 156 meters, and also given that the RL of the instrument axis is given. RL of the instrument axis is given as it is 45 meters. 45 meters. Therefore, what we should do now here, what we have to do here now, first let us calculate the height above the height of the vein, which is kept 1.2 meters above the ground in the station B, at the station B. Now, therefore, this is the height. First, let us calculate the height of the vein, which is kept 1.2 meters above the ground, and it is measured is the angle measured is from station B is 9 degree 54 minutes. Now, H is equal to this distance is known, this alpha angle is measured, this alpha is also known. Therefore, this height, that is height of the vein above the instrument axis from station B, is calculated. Therefore, H is equal to, it is V tan alpha. H is equal to V tan alpha. Isn't it? After calculating this H, now see, after calculating the H, now deduct this. Now, after calculating this H, now deduct this 1.2 meter, then we will get the RL of the station A, RL of the instrument station A, RL of the instrument station A is obtained. Then add the height of the instrument HI, isn't it? Height of the instrument at it is 1.49 meter. Please understand. Now there is where you are confused. See, now this H is calculated. Now this is the H is calculated. Now this is the, we got H, isn't it? H is calculated from H. Now deduct 1.2. Deduct 1.2. Then now we will get the value of this, isn't it? Now height of this, isn't it? Then no 1.2. Then RL of this point is obtained. Now again from here, now add 1.494. I think it is given here. That is height of the instrument. Height of the instrument is 1.494. It is given here. Now see, then we are going to get this, isn't it? The height of this axis. Now, see, after doing this, now apply the third case, that is case 3. Now I will show you. That is, see now this is H is equal to, now this H is equal to V tan alpha, then 27 meter. This is 27 meter, isn't it? Now therefore 27 meter. Now the RL of this axis is known. RL of this axis is known, and the height of instrument HI is known, isn't it? HI is known. Now from there, now see, now this, after calculating this, now the RL of the instrument station at A is equal to, that is RL of the instrument station minus 1.494. Minus 1.494. Isn't it? Minus 1.494. Deduct this, that will give now the RL of the instrument station. The instrument station is, it is 43.508 meters. The RL of this station, RL of the instrument station. Now RL of the vein is equal to RL of the instrument station plus 1.2. Now this is the RL of the vein, isn't it? RL of the vein. And RL of the vein is this. Now deduct this H. Now deduct this H. See, after calculating the RL of the vein, now deduct this H. See, now see, so this is the RL of the instrument station. It is RL of the instrument station plus 1.2, and then minus, deduct it. Then we will get the RL of the instrument axis at B. Now this is the RL of the instrument axis at B. RL of the instrument axis at B. It is, this is already we have calculated. It is 27.23 meter. Is it not? Therefore, the distance between the first instrument station, the elevation between the first instrument station and the second instrument station is HD. Note that HD, the difference between the two instrument axis is 17.426 meters. Got this point? Shall I explain again? Understood?
Yes.
Okay. Then further, see after now HD is known now. HD is equal to, this is not. HD is calculated. Now after calculating this HD, now apply the equation. This is not. Apply already we had. We in the previous cases this we have. Now this H is now see here the B. This is the B and this is D. Now here B is reduced. B is reduced by B minus HD cot alpha 2. Cot alpha 2 is 26 degree 12 minutes. This is not. Substitute this equation, then we are going to get D. D is 164 meters. Isn't that? D is 164 meters. Then after obtaining this, now we can calculate. Now that is HA and also HB. HA is equal to, from here D is calculated, already worked out, and therefore HA is equal to that is D tan alpha 1. D tan alpha 1. HA is equal to. And similarly HB is equal to B plus D. B plus D, that is B is known, D is calculated, D we have calculated and D is known fixed by ourselves, then that gives you the B plus D tan alpha 2. Isn't that? Therefore RL of P is equal to, that is already we know the RL of this we have calculated the RL of the instrument axis at B plus HB, that is P, RL of P, and similarly the RL of the instrument station at A is given, it is 45 plus HA. Now therefore both the answers are same, isn't that? Now that completes the problem. Now our object here is to calculate the elevation of P, and also to find out the distance. Now they have confused here, that is they make you to understand more. Now therefore they have given, now this is 1.2 meter is given here, and RL is given, and HA is also given here, it is 1.494 meter, HA is given here, isn't it? Now first calculate H, then after calculating H, isn't it? Now see, now this is RL is given here, from RL now deduct this, isn't it? Now you just sum up, adding and deducting, you find out the levels, isn't it? There is no much confusion here. Yeah, everything is clearly given here. Now only thing we did here, we have calculated H is equal to, it is B tan alpha 2, B tan alpha. Now this is the another angle measured, that is to make you work more, to make understand more. If they have given the problem like this, isn't it? There is no much problem. There is no much. Only one job is more. One work is more here, isn't it? And if we come to the second another problem, let us discuss about this. Now read the problem carefully. From the ends of the baseline AB 150 meter long. It is 150 meter long baseline, a survey line. 2 points P and Q. One point is P, the other point is Q. Were observed with the theodolite, and the following angles were recorded. Now here horizontal angle PAB is recorded. Now this is 95 degree. That is 45 plus 50, and PBA. Then they have measured PBA, isn't it? Now they have measured PBA from PBA. Now it is 40 degree, and QAB QAB. These are the data given here. The data given, they are the angles measured, isn't it? Now, similarly, that is QAB. QAB, they have 50 degree, and this is total they have measured from here. It is 90 degree, and this is one another 50 degree measured from QA to QAB. And similarly, PAQ measured, it is PAQ, it is 45 degree. They are given here. Also, now these are the horizontal angles measured from the station A and B. And the altitude of P, altitude means that is altitude means what? Altitude of P from A is equal to 22 degrees. That is from station A, they have measured the elevated object. It is the object elevated, isn't it? Elevated object, that is vertical angle. From station A, it is vertical angle measured to P, isn't it? And similarly, altitude of Q, that is to this station Q, that is object Q, the vertical angle is measured from A, that is 9 degree, isn't it? Now, RL of the station A, RL of the station A is 153.583 meters. Now, height of the instrument at A is 1.6 meters. Find the reduced level of P and Q and the horizontal distance PQ. Okay. Now, therefore, see, now this is the problem. This is the real. No, this is the we have plotted in the diagram. Now, this is the real situation of the problem. Isn't it? The instrument is installed and measured this angle and also this angle. The instrument is installed here. They have measured this 95 degree and also they have measured the angle to Q. Now this is the Q, vertical horizontal angle. And similarly from this station, they have measured this angle and also they have measured this angle. That is measured angle measured. Now from this station, angle is measured from Q to A, that is QA. This angle is measured and also they have measured the angle, isn't it? So this is how, and this is by considering the triangles. So this is the angle is calculated, isn't it? The triangle, if you consider the triangle, the total angle of the triangle angle is equal to 180 degree. No, therefore these two, if you consider this triangle, this is known and this is known, this can be worked out. And similarly, if you consider this triangle, this angle is known and this angle is known, this can be calculated, isn't it? That is simple mathematics. And after doing so, now consider the triangle PAB. Apply the sine rule and solve for AP. AP is calculated. See? Now this is known. If you consider this triangle, AP divided by opposite angle is equal to, that is AB divided by opposite angle. Isn't that? AB divided by opposite angle, sine opposite angle is AP divided by sine opposite angle. Isn't that? So therefore, we solve this, we will get AP. AP is calculated. And similarly, applying the sine rule for triangle AQB, apply the sine rule for this triangle. If you apply the sine rule for this triangle, see, now this is known, the angle is known, this angle is known, this angle is known. Therefore, we can calculate AQ. Now this is what? AB divided by sine 50, AB divided by sine 52, and similarly AQ divided by sine 78 degree. Isn't it? Solving this equation, now we will get AQ is equal to 186 meters. Isn't it? And also to calculate the distance between P and Q. Now consider this triangle. This distance is known. This distance is known. We have calculated here. AP is calculated from the sine rule by solving this triangle, and AQ is also solved by considering this triangle. Now that is AQ. Now these two lengths are known, and this angle is known, isn't it? Now, therefore, now let us find out what is the distance between PQ. PQ is the distance. Now apply the cos rule. By applying the cos rule, now see we are going to get, see, now this is the solution we got it, isn't it? By solving this triangle, we have calculated this 136.338 meter, and by solving this angle, we get 186 plus meters length. AQ is this much, and AP is this isn't it? Now, by applying cos rule is equal to PQ is equal to under root AP square plus AQ square plus minus, this is minus, no? This is minus, AP 2 AP into AQ into cos 45. Now this is the cos rule, isn't it? This is the cos rule. By applying this cos rule, see, we will get the distance between PQ. And also in the problem, it is asked to calculate the elevation of P. To calculate the elevation of P, now from A, the vertical angle to P from A is given as 22 degrees. So therefore, now the distance is known and vertical angle is known. Now therefore, calculate the height, isn't it? H above the instrument axis. Now that will give you, now this is RL of the instrument station plus HI plus, isn't it? The distance 136,338 cos 22. That gives you the RL of P. And similarly, RL of Q, same thing. No, please correction this. This is 186 meter. It is 186 meter. Please make a correction here. It is not. It is 136 meter from A to P, and this is A to Q. It is 186 meter. Please correct it. And then see, apply the same thing. That is, no, I think it is written here clear in the correct way. Now RL plus height of the instrument plus AQ cos 9 degrees, isn't it? That gives you the elevation of the Q, elevation of Q. Now that completes the problem, isn't it? Now there are so many problems are available in various textbooks and also in the question papers. Now kindly go through that. Now if you have any queries, now you can come back and you can ask at any time, and you can leave the message in the mail also, where I can solve, or in the next class I can solve those problems. If you have any number of problems, you please bring those problems in one full class. I can clarify all the questions related to the problems or the topic what we have discussed till now, isn't it? Now this completes the trigonometrical level, isn't it? Now then let us proceed. Now see, that is same thing. Now vertical angle how we have measured. The diagrammatically it is shown here. So don't worry about it. Yeah. Now let us discuss about the tacheometric surveying, isn't it? Tacheometric surveying. I will give the fundamentals. We will discuss about it, isn't it? Now please understand tacheometry. What is tacheometry? Tacheometry is tacheometric leveling. It is another method of finding the elevations and distances, isn't it? By measuring the vertical angles, by measuring the angles, isn't it? By measuring the angles, isn't it? The chaining is completely eliminated. No chaining at all, isn't it? In tacheometry, theodolite and the leveling staff and the person, isn't it? No chaining is completely eliminated. Please remember it. Isn't it? It is a method of determining the elevations and distances of the ground or the area wherever we want. Isn't it? In this method, chaining is completely eliminated. No chain we carry, isn't it? Not at all. Nothing is required. And where we are, why this is implied? What is the necessity of doing this? Sometimes what happens, being an engineer, being a field engineer, being a departmental engineer, you may need to propose a railway line. You may need to propose a road construction. You may need to construct a dam, or any project related to civil engineering projects. You may need to do it. Isn't it? Whenever we want to know, first whatever may be your project, first we need to go to the site. Isn't it? First we need to go to the site and collect the data. Now I will give one site for you. Isn't it? Now please check this. Now this is the site. Whatever may be the project, isn't it? The project may be a road, the project may be a railway line, a project may be a dam site, isn't it? Then first job we need to prepare that is to know the topography of the land, isn't it? The undulations of the land. Blindly we cannot say that it is 10 meters above, it is 25 meters above, it is 15 meters down. We can't say like that, isn't it? Now we need to understand. We need to give the approximate value, isn't it? Not as maybe exactly. Now to know that, then the immediate needs. Now, if you apply the tacheometric method, definitely we can come out with some solution, isn't it? We can understand the topography of the land, isn't it? Now, where you are doing the job, what job you are doing it. First, we should know the data information, isn't it? First, we should know the topography of the land. So today we have the most advanced techniques, isn't it? We can calculate. Straight away from office we can do it through our Google Map or any other data. There are so many data available today. Real lifetime data also available. Now we can employ those data. But basically now this is the one method we are employed in the olden days, in the previous days. Now even now sometimes we may need to do it. If you are in a remote place, we don't have the internet, if you don't have the facility, then in the remote place, then we need to do this. Isn't it? One should know about it. Now, therefore, now let us see what are those, how to do that. Isn't it? Now, again, the instruments employed, instrument used. It is a theodolite. A theodolite can be employed. A theodolite is a transit theodolite. Is called a tacheometer. Isn't that? A transit theodolite may be called, that can be used as with some additional features, isn't it? A tacheometer is a theodolite. A tacheometer is a theodolite. The theodolite can be employed with additional features, isn't it? Now, therefore, now usually what we are going to do, we will read with respect to the crosshairs, isn't it? There are two crosshairs, that is, one is perpendicular to each other. Usually, while measuring the horizontal angle or vertical angle, whatever may be, we are bisecting the coincidence, isn't it? Coincidence of these crosshairs. Now, whereas in this case, in the tacheometer, we need two more additional related a stadia, isn't it? Diaphragm. A small glass piece marked like this, isn't it? Now, in the normal theodolite, regular theodolite, in theodolite, we have only two things, isn't it? One horizontal line, the other one is. So, in many instruments, normally there are, sometimes it's available, that is these lines, that is one is the web lines. These are called stadia lines. These called stadia lines. This is stadia line. This is stadia line, isn't it? They different in a different manufacturer will supply the instrument with the different configurations, isn't it? Ultimately there are three lines, isn't it? Three horizontal lines. They are called stadia lines. They are called web lines, isn't it? Stadia. Is understood? A transit theodolite having a stadia telescope, that is a telescope fitted with a stadia diaphragm, telescope equipped with two horizontal hairs called stadia hairs, in addition to the regular crosshairs. Regular crosshairs, only two crosshairs which is perpendicular to each other, and there are two more, one at the above, the other at the below at the equidistance, isn't it? Now this is called stadia lines. Stadia, isn't it? This is the instrument one, theodolite fitted with stadia diaphragm, isn't it? The instrument, there are two instruments used in tachometer. One is theodolite. Tachometer, it is called tachometer. A theodolite fitted with stadia diaphragm, isn't it? A small glass piece marked like this, So they are called stadia diaphragm, isn't it? It is inserted in our telescope. And the another instrument, now this is the leveling stadia rod. It is called stadia rod. It is a graduated rod, isn't it? Graduated rod. Graduated rod. It is marked meter, then decimeter, centimeter, isn't it? Our ordinary leveling staff can be employed as a stadia rod, isn't it? A stadia rod is a graduated rod, isn't it? But depending upon their construction, sometimes it is folding type, sometimes it is soft pitch type, not depending upon the convenient, the availability, the instrument available with you. A regular leveling staff can be used as a stadia rod. A regular leveling rod or stadia rod. A regular that can be used. These are the two instruments employed in tacheometry, isn't it? And now these are the different types tacheometric method. That is, one is stadia method, the other one is tangential method. The one is in stadia method, fixed air method, the other one is mobile air method. It's a mobile air method and fixed air method. Okay, I will explain little later. Now let us concentrate now only about these two, that is stadia method and tangential method. Isn't it? Then we will come back in the next class. Now we will discuss about all these things, a little more about it. Now this is where you have been sent to ascertain to make a project, isn't it? You have been sent to ascertain or do some job. Now how we are doing it? Now here the beauty of this method is, see now this is how we can do it. Now in one station, from one, the advantage of this method is, from one station, from one instrument station, see, we can take the staff reading, we can measure the elevation of this point, we can calculate, we can compute the elevation of this point, we can calculate the horizontal distance from this point, isn't it? This is one instrument station where we install the instrument, then take the stadia readings, isn't it? But you need to go there. Inevitable. We can't do anything, isn't it? It is our job now. Being a civil engineer, it is our job. If you want to do some project, then we need to travel. We need to carry the instrument. Wherever the location, maybe with any difficulty, any problems, if you execute, we need to, isn't it? Therefore, now there may be a difficulty in moving from one place to the other place, but we need to do it. To understand the topography and to propose some project, we need. Now install the instrument, take the stadia readings, isn't it? Take the stadia readings. So here from one station, now we can work out the elevation of this location and also the horizontal distance. Similarly, from the same station, we can work out the elevation of this station, this location, and also we can calculate the horizontal distance, isn't it? And similarly, we can see any number of readings we can do it, isn't it? From one station. Now this is one side I have shown. Now this the other one side I have shown here. The other side also we can, isn't it? Understood? Within the limits of our instrument, within the limits of our telescope, isn't it? The range of the instrument, maybe 1 kilometer, maybe half kilometer, maybe 2 kilometers, depending upon the, isn't it? Depending upon the range of our instrument, we can take in number of. So from one station, if we are able to calculate the elevation of this point, elevation of this point, elevation of this point, elevation of this point, like 100 number of elevation of so many points. If you plot, if you plot distances, so we can plot the contour map. Can't we do it? After knowing the elevations of number of points and distances, can't we prepare the plan? We can prepare the plan, isn't it? Our major problem is solved, isn't it? Major problem being an engineer, now we can propose, we can say, so much cutting is, so much filling is there. The road can be proposed from this end to the other end. The railway line can be proposed. The dam can be proposed at this point. Approximately we can come out, isn't it? And please note in this method, the value what we are going to accuracy level is little less when compared to the other method, chaining or any other method. It is the approximate method. Approximate method means the level of accuracy is little lesser, isn't it? You may not get 100%. Now depends upon how you are executing the project, isn't it? How you are going to take up the reading, stop reading. How you are going to take up the recording those values, isn't it? Now therefore, now this method can be employed. The tacheometry can be employed to calculate the elevations and distances of different points from one station by taking the stadia reading and also by measuring the vertical angles, isn't it? Now how many stadia readings are there here? There are how many readings are stadia lines? Stadia lines are there are 3. This is to the center and this is to the top and this is to the bottom, isn't it? Understood now? What is tacheometry? Understood? Got it? Tacheometry. Now this is here again. I will give one more. I will show you one more slide. Now can you understand this? This is same problem, same location. This is also tacheometry. It is also tacheometric method, isn't it? Sometimes we may not be able to. The instrument is not fitted with the stadia. Instrument is not fitted with the, isn't it? Diaphragm, stadia diaphragm. Under those circumstances, what we are going to do is what we will do at a fixed distance in the leveling staff, large stadia rod, in the leveling fixed distance. Now we are measuring the vertical angle theta1 and vertical angle theta2, isn't it? And similarly measuring the vertical angle theta1 and vertical angle theta2 to a fixed distance, isn't it? Understood? Got it? Understood the matter? Now this is in the previous case. What we have done? We have taken in the previous case we have measured stadia reading, 3 stadia reading, isn't it? And 1 vertical angle for each station, isn't it? In the next case, now here we have measured 2 stadia readings and two vertical angles. Understood? So this method is called tangential method of measuring the tangential method of tacheometry. Isn't it? This method is called, isn't it? And this method is called stadiometry. Because stadium readings are primary here, one vertical angle, isn't it? Now in this case, tangential angles are measured, isn't it? Tangential angle, theta 1 and theta 2, and stadial lines, isn't it? Understood? No stadial lines. It is tangential angles at a known or fixed distance in the leveling stock, isn't it? Now this is how we are executing. Now these are another example shown to you to understand much better or more. And now this is how I want to present you the tacheometry. And now let us continue this in the next Wednesday class, isn't it? Now I will stop now. We will continue in the next Wednesday. Thank you very much for everybody. Thank you, Lord. Thank you so much.